Welcome to EDU World Space.
In problem 34.2, we're given the height of a mirror, the distance between the mirror and the eye, and the distance between the tree and the mirror. And I drew in a diagram here, so I labeled HM, which is the height of the mirror, LME is the distance between the eye, which is this black dot, and the mirror, which is the vertical line, and LTM is the length from the tree to the mirror. And we're asked to find the height of the tree. So the way we'll solve this problem is to draw some rays from the top of the tree to the top of the mirror, because we're told that the tree covers the entire height of the mirror. So let's draw in some rays, and then it's going to be reflected to the eye. That's how the eye sees the tree, so the rays are reflected there. And then we want to construct an image of the tree from these reflected rays. And we know that for a plane mirror, the height of the tree and the height of the image formed are the same, and the distance of the image is the same, will be the same distance as the object of the tree, which is the tree from the mirror. So let me draw the tree over here. Let's make that green. And it's supposed to be the same height and the same distance. And then let's draw in the blue rays. Okay, so these are just extended backwards into the mirror. And observe that we have actually two triangles. So the one formed by this black line and these two blue lines, and a larger triangle formed by these long blue lines and this green line. Let me label this HI, which will be the height of the image here. And this will also be the height of the tree, because we know, for example, that the magnification is equal to y prime over y, but for a plane mirror, m is equal to 1. So that tells me that y prime is equal to y. So the image and the object, they have the same height. So if I find the height of the image, then I know the height of the object. So in order to find this, let's label in some angles. Let's just call this angle theta. So these two angles are the same. So we'll call this theta. And let me define another length. This, namely this length here. So this is the length from the eye to the image. Okay, so that's the length that goes here. Okay, so I'm just gonna draw these two triangles on the next page, but let's be clear that we understand that this height is half of the image height, and this height here of this black line will be half of the mirror height. So I have these triangles which I'll just draw all in black. So I have my angle theta, and I have a triangle here with height HM over 2. and this one has height hi over 2, and this length was a length from the eye to the image. So if we look at, let's say, so this total length, and this small length is the length from the eye to the mirror. So if we look at the tangent of theta for just a small triangle, it's the opposite over adjacent. And the big triangle also shares the same angle with the small triangle. So we have, again, tangent of theta is equal to opposite over adjacent. And obviously, tan of theta is equal to tan of theta. So we can equate these two parts. So we have hm over 2lem is equal to hi over 2lei. And we wish to find the image height. So hi, I'm just going to move the 2lei over on this side. So I have lei over lem times hm. And we actually have these particular numbers. They're given to us. So before I move on, let me just write down what LEI is. So remember, this was the the sum of the length of the eye to the image to the mirror plus the length of the mirror to the image. And these two were given. So that is equal to 35 centimeters plus 2,800 centimeters. And that gives us 2,835 centimeters. So let me just kind of write this down here. So that's 2,835 centimeters divided by 35 centimeters times the height of the mirror, which is 4 centimeters. Then we get, for a final answer, 324 centimeters, which is equal to 3.24 meters. And you could have obtained the same results without using this tangent by just using the properties of similar triangle, but this is sort of a derivation of those properties.